Hello everyone, this is Shrikant again, and in this video we'll be talking about drawing the conventions to represent some of the machinery parts that we use in machine drawing. So we will just draw these parts in AutoCAD, and we will try to make them into a block so that they can be repeatedly used at different places. So let's begin. First up we have something called straight knurling. We have knurling like this, and this will be present throughout the periphery of the object. This is for gripping purpose, so that we can rotate this part very easily. So actually it looks like this, but during for convention's sake we will be drawing only like this. So we'll just be drawing the right side views of the objects. The left side we'll just leave it, because this is how the object actually looks like, and this is what we are supposed to draw in AutoCAD. So let's begin. Since none of the dimensions are actually given, I'll just go with some random dimensions. I'll just take this length as 80 for shaft, and then I'll take offset, and I guess a length of 8 will be enough on both sides to get the shaft. So this I'll take it as the shaft, and I'll just draw a vertical line to get the starting point here. And then some convenient distance in horizontal direction I'll have to take. I'll just take 20 in this direction. So then I'll have to do is I just need to now trim these things off, and yeah, I'll need height as well. So what height would I take? I'll take offset again. I guess somewhere near here will be good enough. So I'll just take 22 as the offset, and I'll just offset it. Then I'll just take fillet and modify its radius to something like 2, and I'll just go on filleting all these corners. Yeah, so now we have something which looks good enough. Okay, this should do. If the radius of 2 is pretty small, you can change the radius again to something different and go back and fillet it. After doing the fillets, of course, you'll have to remove the previous fillets that we had done. Now we have to show this round part. This is the representation of the shaft, and because it is completely filled on the inside, it means that the shaft is not hollow. So to do that, we'll just use arcs. I'll just use arc starting point. You can get it anywhere here, and I'll click somewhere here, and then I need a straight line from here. So just use object tracking or something. Also just let me take a line first, then I'll take an arc like this, and then I just need to convert this into that. So I'll just use mirror to mirror it to the bottom, and one more mirror to mirror it on this side. So this is all we will need, and I just need to hatch this inner part of the body. I'll just go with hatch pattern. I'll go with this pattern. This is appearing very small, so what I have to do is I have to change the scale of this to something smaller. I'll just go 0.1. 0.1 seems to be too small. Let's see if we can make it a little larger. So I'll just go with 0.2. Yeah, that seems to be working perfectly. Okay, so now we need a few horizontal lines in the center, and for that what I'll do is I'll just draw a rectangle, just an imaginary rectangle at the center, and this inner part I'll just hatch it with the horizontal lines. If you want to keep it at the center, just pick the midpoint and keep it at the center, and then go to hatch again. You can give it the command H, enter, and instead of taking this particular pattern, I want horizontal lines. So these lines itself you can convert into horizontal lines if you give an angle of rotation to be 45. Yeah, the 45 now you should change it to minus 45. Okay, because we want it on this other side, opposite to that side. Okay, that seems to be working. I just fill it, and you might want to change the scale again. Go to properties, scale, reduce it slightly. Let's go with 0.4. Yeah, or 0.5 I guess would be much better. And then just delete the outer rectangle. So this is how the representation is going to be done for this particular shaft. Now I can just copy this part straight away, copy it down, and I'll just modify this thing. I'll draw again a rectangle at the center somewhere here, move the midpoint over to this point. Yeah, and I need a slightly different kind of hatch this time. So go to hatch and properties and take this one over here. Uh-oh, I guess we have to rotate this by 45 degrees. So let's go back, select the hatch, properties, and change it to 0. Okay, I guess we have it. Just delete this outer part, and there we have it, the convention for diamond type of knurling. And we have a shaft over here, and the shaft is having a square shaped end over here. So these kind of ends are generally used for mounting the other rotating parts, like you can say the steering wheel kind of a knob, which needs to be rotated to have the shaft rotate in a particular direction. So for that, I'll just go ahead and copy this shaft again, and I'll just use some convenient lengths to draw the shaft. So I'll take an offset of, let us say, 10 on both sides, and then I'll just draw a line over here and remove this. Next offset I'm going to take is slightly less, and then I'll just have to trim this off. Let us say that is coming somewhere up to here. Again, I'll just trim the unnecessary parts off. Again, I need to take an offset. I'll go with 5, offset of 5. Again, the back side we need to just delete it. I need another straight line over here. So the lengths and all, you need to draw it suitably. I've just taken some random lengths over here, and yeah, so these two parts, they are circular. So how do we represent the circular part? Same as before, we just need to draw a line, temporary line here. Then I'll just take an arc, and I'll just have to mirror it. First about this part, and then about the horizontal. Yeah. So this is the shaft. Again, we can go to the hatch and do a similar hatch over there. I need this kind of hatch. Properties, I need 0. And scale, I need 0.2. Yeah, so you can see that has been changed. So now this symbol that we have made here, it ensures it means that the shaft is circular at this point. If you want to show the circular part over here, you can either show the cross section, or you can just give the diameter when you are giving the dimensions. Over here, this is where we are concerned with. So here, instead of just drawing the cross section and having the need to show another view of the object like it is shown over here, we can just draw a cross mark over here, and this cross mark would mean that the cross section of this particular part that is appearing in front view is actually square. Let's go ahead to the next one. This is just a circular plate with holes drilled on a circular path, you can say. So there are a lot of holes. When there are a lot of holes like this, we need not draw each and every hole on it. We just need to draw it like this. Let us go ahead and see how to draw that. I'll just take a circle, let's say of 35 radius. I'll need another circle with the same center. You can just touch it to get the center, and just go with 25. Okay, then I'll just have to draw one circle of, let us say, radius 5. Okay, that's enough. So only one circle we need to draw, and to show the other circles, what you have to do is just take a line, slightly increase it on both the sides, and this line I'm going to create an array for. So array command is AR. So array of this point, enter. I need a polarity, of course, enter. And now it's asking me to select the center point. This is the center point. Now by default it will just create 6 copies. I have to change the copies over here, so I need a total of 12 of these. You can see the lines have got multiplied. Just press escape, and then you can draw a set of more shafts, one horizontal, one vertical, and you can slightly increase their sizes. Okay, so that's it. So this is how we represent number of holes. Next, coming to the bearings, you can see here the bearings look like this, and they may have circular balls present within themselves, or they may have cylindrical balls like this. Cylindrical balls, because they have line contact, they have greater ability to take more loads, whereas the circular ones are slightly more smoother. So it depends on what kind of bearings you want to use. Regardless of them, when we have to draw it in the diagrams, we will not be showing all the details of the bearings. We'll just be drawing it like this. Let me proceed to see how to do that. I'll just take an axis as usual, then I'll take an offset. I'll go with 10 in the beginning. Okay, 10 on both sides, then I'll just trim it off to this point. Okay, and I'll just go with offset of 8 next. Backside part I'll just have to drill it. Okay, so this has given me the shaft I wanted. Now in order to show the bearings, I need not, as I told, show all the details. I need not show the balls, that there are 2 rings, one is on the inside, other outside. All these details we need not show it. So details about the bearings and all the bearings, standard bearings are available, of course. So we can just put a leader line and show the details, write the details over there. So I'll just go with a rectangle, slightly rectangle over here. I've just done a square. I'll just mirror it at the bottom. Fine, and then I just have to draw cross marks like this. Just try to draw cross marks. So you can mirror it after drawing the cross marks, or since I have done it this way, I can just copy this down to this rectangle as well. So this is how we do it. Of course, just like in the diagrams before, I've shown you how to show the shaft. I just have to take an arc, mirror it to sides. Then I'll just have to go with hatch once again. Yeah, that's it. So I guess this is how we do it. You can just go with corners. You can just trim off all these side parts. Okay, so this is how we represent the bearings. Next, coming to the external screws, you can see the screws have a lot of threadings present on themselves. Maybe helical, maybe having different cross sections and other stuff like that. But to draw all these threads, it's going to take a lot of time. So if we don't want to waste a lot of time while drawing all these details, and they're irrelevant. We can actually just put a leader line and mention all the details, all the details that define the kind of cross section, the kind of page, and other details like that. So here as well, we'll not be drawing all these threads details. We'll just be drawing it like this. So you can just start with the axis once again, and then you have to take offset on both sides. I'll just go with an offset of 12. Okay, so I have offset here to take. Then the center part where there is no threading, I'll just have to decide some convenient length for that. So this middle part is not having a threading, and then towards the end you can just go on to draw a line, an arc, and the same I can just do it on the other side. If I mirror it about the center line, of course I'll just get it directly. And then I'll have to take a small offset depending on the pitch. Whatever is the pitch, depending on that, you'll have to take a small offset. So I'll just get offset of 2 mm. So 2 mm here, 2 mm here. So this left side part and the right side part, these are the two parts which have which actually have the threadings. The inner part doesn't have it, so inner part I just have to trim it. So this is how we represent the screw threads. Of course, when you're drawing the side view of this, we'll have to take a circle of the same size. Let's draw it here and then just move it here, and then I need another circle of this size, and that will go in the center of this circle. Now we need not have the complete circle present over here, we just need a part of it. Of course, we might need to draw the axis lines and make them slightly larger. So if you have observed, I'm using the scale command to increase the size of these things so that it happens uniformly on both the sides. And I just have to remove part of this. So instead of using trim command, I'll just go with break command. That's the easiest way you can use to break it, somewhat like this. Then I'll just rotate it slightly so that this part comes a little above this, like this. So this is how we show the external threadings. Coming to the next part, we see here that we have internal threadings over here. We have a hole present here, and that has been tapped to show the threadings inside. So how do we draw that? So let me just go with and take a rectangle to represent. I'll just go with rectangle to represent the outer body, and in this body we'll be doing the hole. So for the hole, first we need to draw the axis, and from the axis we can start taking the offsets on both sides. Then at the end we just draw 30 degrees from both sides. That will be good enough. Okay, this part will go away, this is not important. Let me just go ahead and do it to here. Okay, so now we have to show the threadings. So threadings will be showing them on the outer side. For the screw, we had shown the threadings on the inner side, but here it happens opposite. We'll have to go on the outer side. So I'll just go ahead and take the same pitch over there, and then let us say the tapping is done only till here. Generally for a hole, the process that is taken up is, if we first drill the hole, which will not have any threadings in it, and then we use an instrument called a tapping tool or something like that to put the threadings on the inner sides. So this is how it's going to appear in the section. So we can also show the broken section. If you want to show the broken section, you can just draw a spline or something over here, trim the extra parts, and draw the hatching on the inside. Of course, you might have to change the scaling to something that is more suitable. Let's go with 1.2. Yeah, that's good enough. Okay, now when we have to show the side view of this, because this is the first angle projection we are drawing, the side view we need to draw it on this particular side. So I'll just go with the two circles, one circle, two circles, and these two circles I just have to move them over here in the same line. They should both be in the same line. Now you can see the outer circle is incomplete over here, so the outer circle we have to keep it incomplete. So I'll just go ahead and draw the two axes, and I'll just scale them so that they slightly appear larger. Then I'll go ahead with break, and this time the break command I have to apply on the outer circle, somewhat like this. Okay, so this is how it's going to appear the side view. Of course, if you want to show the outer body as well, you might as well start somewhere here. Okay, it's gone. Okay, just use stretch command to increase it. It's happening wrongly. I'll just go ahead and draw this rectangle from here, and I'm just using tracking option over here to get this particular view. So you can also show the broken view. If you want to show the broken view on one of the sides, you can just draw again some spline, trim the extra parts on both the sides, and also these parts over there. So this is just a broken view showing the inner holes. And yeah, so this we have here is the assembly. So we have a hole containing the internal threads and a screw inserted into it. So what it can technically do is you can just create a copy of this. You can just create a copy of this, and you can just show this part as if it's inserted. So just copy this again and insert it, let us say till some convenient point. Fine. So one thing to be kept in mind here is that the threadings for these two, they have to match exactly. So just use the scale reference part to just increase this over there. Okay, so it has got to be like this. So the threads of the hole, they need to match exactly with the threads of this this screw. Then we'll just have to remove this edge as well, because now it's assembled, though that won't be visible. So this is how we draw the assembly. A small part of that is shown here, but we need not have the complete part over here. We'll just remove these parts, extend this part slightly, and just remove it. Yes. So this is how the assembly is going to look like. I guess the video has become too long. I'll just show you how to make a block out of this. So if the same thing is repeating at many places, generally what you do is you just create a block and copy the blocks at different places, or insert the block at all those places. I'll just explain the advantage of having the block as well once I create it. So to create a block, you just have to type in B, enter to create a block. So a dialog box like this will appear. It'll ask you the name of the block first, so you can just say, give the name like this is for straight knurling, and then I'll just have to select the objects. To select objects, we have here under objects, there is a button called select objects. Click on that, then select all the objects that you want to be a part of the block and press enter. After pressing enter, if you have to pick a point, fine, so this point will be used for a reference for the block. Let me just pick this inner point so that I can place this block easily at the intersection of the shafts if it is inserted into some object. So a point is picked, the coordinates have appeared here, objects have been picked, and the name has been given. So after doing these three, you just have to click OK. So now you can see this has become a block. So now the lines are not separate, they are remaining together. Once we select something, it's remaining together, and it's also handy to actually move it from one point to another. Now if I copy this, so if I copy this or if I insert this, the insert command is I enter, and as soon as you give the insert command, you will get all the blocks that you created over here. You can select whichever block you want to insert, and then you can click OK. So now you can see I'm able to insert the block as well. If you want to scale the blocks, the scaling also is available here. So you just have to select, after selecting you can provide the scaling as well over here, and click OK. So after I click here, I have the option of scaling it. Now you can see it's undergoing a non-uniform scaling depending on how I'm moving in either in X direction or Y direction. So I can just choose some convenient scaling over here and click. So I'll just tell you what is the advantage of using the block. The main advantage of using the block is, suppose you put this particular component at hundreds of different places, and later on you come to know that it's not the straight knurling that we need, but we need the other type of knurling over here. So it's not recommended for you to change it 100 times, right? So in case you have used blocks, all you have to do is change the definition of this block, and all the copies of that block will automatically reflect that change. So I'll just go to edit this block. To edit the definition of this block, what you have to do is you just have to double click on the block. A box like this will appear showing you all the blocks, which block you want to edit. So select the block you want to edit and click OK, and then you are editing in the block. So inside the block, you can select the different parts and even separate them out if you need to. So now what I need is I need to change this hatch to something else. So let me say I'll just go with something like this. Now it has become too dark. Just go back to block, select this hatch pattern. I'll have to use a different pattern. Let me just expand this. Yeah, so this is the pattern I want. Also I want this to be rotated, so just change the angle to 0 degrees. Yeah, so this is what I was expecting to happen at all the places. So let's draw a circle to ensure that this is indeed has happened. And just close the block editor. If it asks to save or not to save, just click on save changes, and that's it. So all the copies that you had placed over there, they are showing us the changes. Wherever scaling is there, it's showing up. Rotation is there, it will show up, and placement is there, it will all show up exactly as the block. So this is the main advantage of using the blocks. So after learning to draw all these conventions, try to convert them all into blocks and save them appropriately with the different names, and you should be able to use these blocks wherever these kind of geometry is needs to be represented. You might argue that once the blocks are created, it's very difficult to make the changes and all. So these changes are possible with something we call as the dynamic block, and this I will cover in some other video, because this particular video has already become too long. We're around 27 minutes. Thank you for watching with patience till the end of the video, and of course, if you like this video, give us a thumbs up and stay subscribed to our channel for all the future updates. Thank you.